All right, guys, welcome to this page of the notes. And what we're going to do here is we're going to take a look at that second objective or learning target, which is using synthetic division to divide polynomials that are bigger than a monomial. Now, this method is much, much faster than algebraic division. However, the problem is it only works in certain cases, and that's what I want to mention to you first. When does it work and when does it not work? So, however, it only works when the polynomial is a divisor of the form x plus or minus k. Let me explain to you what this means. Please notice a couple of things. First of all, that x is to the first power. Right? So your divisor has to be an x to the first power. If you have an x squared or an x cubed or an x to the fourth in the divisor, synthetic division isn't going to work. Second, please notice that the coefficient in front of the x is a 1. That x must have a leading coefficient of 1. If it doesn't have a leading coefficient of 1, synthetic division will not work. And then k is just a number, right? It's some constant. So the things that'll work, examples would be x, oh, sorry, hold up, that's a highlighter. Things that will work. So let's put will work. X plus 2, x minus 4, x plus a half, x minus 1/4, right? All examples of things where synthetic division will work. You have an x, they're all to the first power, they all have a leading coefficient of 1, and they're all plus or minus some constant, 2, 4, 1/2, 1/4. Those will all work. Things that won't work will not work. So some things that will not work. X squared minus 4. Can't do synthetic division. The x is not to the first power. 3x minus 2. 3x minus 2 isn't going to work because your leading coefficient is not a 1, it's a 3, right? So that's going to be no bueno. I don't know, what else could we have here? I don't know, maybe 4x plus 1/4. Again, for the same reason, you don't have a leading coefficient of 1, so synthetic division is not going to work, right? So anytime you have something that looks like this, you're good. Anytime you got a leading coefficient that is not 1 or power greater than 1, synthetic division is just not going to be. Algebraic division is absolutely going to be the way to go. So let's go ahead and jump right into this. I did solve a problem for you here showing you how it works. I've also solved a problem for you here on this page showing you how it works. But again, we don't learn anything by going through an example problem that's already been solved, at least when we're doing it together. So let me jump right here to this page of the notes. And we are going to use synthetic division to go ahead and do this problem. Now, of course, absolutely algebraic division will work. Algebraic division will always work. But in this case, I have a leading coefficient of 1. The x is raised to the first power, and I have a constant of negative 2. So if you wanted to, synthetic division will work. You do need to make sure, though, that you still have every power of x represented in the numerator. For synthetic division, you still need to use placeholders, which is nice. Both algebraic and synthetic division require a placeholder. That just makes it easy to remember. Whenever you're doing division of polynomials, you got to use placeholders. Either method, both of them need placeholders. So x to the third, x squared, x to the first, x to the 0. Everybody's there. I don't need any placeholders. We're all set. Here's the way synthetic division works. The first thing you need to do is take your divisor, set it equal to 0, and solve. X minus 2 is equal to 0, which means x is equal to 2. So you're going to do your synthetic division with a 2. Let's go ahead and put that guy inside of a box. All right. A little bit below that box, you're going to go ahead and draw your bar, which will separate your work from your answer. All of your work will go up here. Your answer is going to be below the line. Now, and what you need sort of right next to your box, leaving yourself a little bit of space. You don't want them right on top of each other. We completely ignore the variables. The variables and their powers no longer matter. We don't care. Don't care. All you want is the coefficient of each term. My first term is a 3x cubed. X cubed, who cares? Don't care. I just want the 3. My next term is a negative 2x squared. X squared, nobody cares. We don't care. All we want is the negative 2. The next term is a 7x. All I care about is the 7. And the next term is a 4. All I care about is the 4. Okay, that's it. It's just that simple. You have now set up your synthetic division problem. You are all set up. You're ready to do synthetic division. Again, here's how it works. Take the divisor, your denominator, set it equal to 0 and solve. Whatever you get here is the number that you're going to do synthetic division with. It goes inside that little box. Then, after you check to make sure that you don't need any placeholders, because if you need a placeholder, you'll need to put that in there. But after you check to make sure you don't need any placeholders, you just simply pull out the coefficients of each of the terms in the numerator and just write them next to the box. Now we're ready to do synthetic division, and here's the way it's going to work. You're going to love it. It is so simple. I'm about to blow your minds. Here we go. Step number 1. You take that first coefficient, you just simply bring it down and drop it below the line. So I bring my 3 down. Now, from this point forward, it is multiply and add until you run out of numbers up here in this top row. All right? Once I run out of numbers, then my process has completed. Synthetic division is over. So multiply, add, multiply, add, multiply, add until you run out of numbers. So multiply comes first. 2 times 3 is 6. So I'm going to write a 6 right here below my negative 2. 2 times 3 is 6. And now I add. Negative 2 plus 6 is a positive 4. Then I multiply. 2 times 4 is 8. And then I add again. 7 plus 8 is 15. Then I multiply. 2 times 15 is 30. Then I add. 30 plus 4 is 34. Synthetic division is done. You have now completed the process. Again, the way it worked, you bring down the first coefficient, bring that first one down below the line, and then it is multiply, add, multiply, add, multiply, add until you run out of numbers. 2 times 3 gets me 6, add them up. 2 times 4 gets me 8, add them up. 2 times 15 gets me 30, add them up. Now, here's the way that you get your final answer. So easy. You take a look at the degree of the polynomial that you started with. My original polynomial was a 3rd degree. Right? Because my largest power of x is to the 3rd power. So this is a 3rd degree polynomial. That's what I started with. Your polynomial, your answer will be 1 degree less than the polynomial started with. Well, since I started with a 3rd degree polynomial, my new polynomial, my reduced polynomial, is going to be a 2nd degree polynomial. So 3x squared plus 4x plus 15. Again, right? X squared, x to the first, x to the 0. But that's interesting. I still have this 34. Well, that's because that's your remainder, right? This last number is always going to be the remainder, what's left over after the division process. Since it's a positive 34, we're going to go plus 34. And remember, we always write a remainder over the original divisor. That is synthetic division. Again, we're going to practice it a few more times just so you get used to it. It is so much faster than algebraic division. You're really going to like it a lot. The only problem is it doesn't always work, right? It's a very specific case where it works. But let's go ahead and do another one. Now, I know initially you're looking at this when you're like, hold up a second, I have a leading coefficient that's not 1. Sometimes in these problems we can fudge it, and here's how. 3, 12, 15, 6, 3, and 9 are all divisible by 3. So we're going to divide everybody by 3, and what I'll have then is something that is, I can use synthetic division for. So 3 divided by 3 leaves me with an x cubed. 12 divided by 3 is a 4x squared. 15 divided by 3 is 5x, and 6 divided by 3 is 2. 3 divided by 3 is x, and 9 divided by 3 is a minus 3. So again, what I've done is I've recognized, hey, everybody is divisible by 3. They're all divisible by 3. So I simply divide everybody by 3, and when I do that, well, there you go. I wind up with, right, something with a leading coefficient of 1 to the first power. Synthetic division will absolutely work in this case. Just make sure you don't need a placeholder. 3, 2, 1, 0. I don't. So here we go. We set it up. X minus 3 equals 0, which means x is equal to 3. That's the number that goes inside of my box. I pull out all of my leading coefficients, which are a 1, a 4, a negative 5, and a 2. I draw my bar to separate my work from my final answer, and step number 1 is to bring down that first coefficient. So the 1 comes down, now you multiply and add until you run out of numbers. 3 times 1 is 3. 4 plus 3 is 7. 3 times 7 is 21. Should leave me with 16. Yeah, 16. Okay, so then you would do 3 times 16. Let's see here. I got a calculator right here. Let's do that real quick. Let's see. 3 times 16, 48. Which is going to leave me with, what, 50? When I add those guys up. And so now, again, remember that last number is always going to be your remainder. My original polynomial was a 3rd degree. So my new polynomial is going to be 1 less than that. So I know that it's going to be an x squared plus 7x plus 16 plus 50 over x minus 3, which was the divisor that I did my synthetic division with. And so there is my answer thanks to synthetic division. Guys, hopefully that process makes sense. We're going to get a lot more practice with it here and some more problems on the next page of the notes. So head on over there and I'll meet you guys there.